Good morning, everyone. I welcome you all for today's session on projection of isometric projections. Let us not waste much of our time. Let us proceed to a problem. I have a sphere of diameter 45 mm rests centrally over a frustum of a cone of a base diameter 60 mm and a top diameter 40 mm and a height 60 mm. Draw its isometric projections. I have a sphere of diameter 45 mm and it is resting over a frustum of a cone. Frustum of a cone is nothing but it is the cut portion of the cone at a height of 60 mm. It is a cut portion of a cone. Cone is what? It looks like a pyramid where at the bottom I have a circle and it is meeting at a apex at a certain height. But here frustum means what? I'm cutting exactly parallel to my base. I'm cutting the cone exactly parallel to my base and it looks like a frustum. So let us draw this. Initially, so let me draw the top view first. Where I have a outside diameter as 60 mm. So I'm going to measure it with 30 mm. The diameter is 60, so the radius will be 30 mm. I'm going to draw the base first of 60 mm diameter. Okay. Then I'm going to draw the top base whose diameter is 40 mm. So the radius will be 20 mm. I'm going to measure the radius of 20 mm. Okay. I'm going to project this upwards to my XY line. So let this XY line be much smaller, near to us. I'm going to draw a XY line here. This is my XY line, this is my VP, this is my HP. I'm going to project this. This is my center line. I have a height of this frustum of a cone. The height of this is 60 mm. So I'm going to add a 60 mm height here. And I'm drawing a center of this axis. So I'm going to draw the axis line here. This is my height. I'm projecting it to 60 mm. I'll just close it to 60 mm. Then I'm projecting this sideways, the larger circle, and I'm joining this. This portion is my frustum. This portion, whatever I have, it is a frustum where this is the bottom base. This is my bottom base. And it is also a circle of diameter 60 mm, which is given. And this is a cone. When I extend this up, it meets at a center point here somewhere. But at certain height, that is at 60 mm, what we have done is we have cut this cone exactly parallel to the base. such a way that again this also looks like a circle, and this upper diameter is given as 40 mm. This upper diameter as it is been given as 40 mm. And also above this I have a 45 mm diameter sphere. So 45 divided by 2, it is 22.5. So somewhere here I'm just drawing a circle sphere. So this is a sphere of 45 mm diameter. When I see the same, I'm going to draw that circle here on the top view at 45 mm. Okay. So this is what I have drawn it in 2D, but I need to draw the same in 3D. I mean in isometric projections. So for which, what I'm going to do is I'm going to convert this circle to a square first. I'm going to draw a outside square. Then I'm going to put this circle in isometric projection where circle happens to be a ellipse. So what I'm drawing is I'm drawing a square block first of this 40 mm and 30 mm diameter. For my understanding, I'm going to draw it from this corner. So say for example, this is corner 1, this is corner 2, this is corner 3, and this is corner 4. Then inside I have one more square at the top because it is at a certain height of 60 mm. This inside square again I'm going to start with this corner, second, third, and fourth. So to begin with, I'm going to start with corner 1. So let me go back to the isometric lines. These are my isometric lines. I'm going to draw a square of 60 mm. So I'm going to count, I'm not going to draw it with the measurement with the scale. I'm going to count the number of blocks. I'm going to count the number of blocks here. So please don't make a mistake by measuring it with your scale. Here along the line on the blue lines, I'm going to count the number of blocks. This is 1, 2, 3, 4, 5, 6. Then from here it is 1, 2, 3, 4, 5, 6. Then from here it is 1, 2, 3, 4, 5, 6. So I've got all the 4 corners. That is, this is corner 1, 2, 3, and 4. You don't write these 1, 2, 3, and 4 again. This is for your understanding. I'm writing it. It should not be written here in the isometric projection lines. So I just draw a square now. On this 30-degree line. Okay. Once I'm done with this, now what I'm going to do is I'm going to draw a circle which looks like an ellipse here in the isometric projection. For which what I'm going to do is from this corner, I'm going to join the midpoint. From this corner, I'm going to join the midpoint. From the opposite corner, I'm going to join the midpoint here, as well as to the opposite edge here. So once this is done, I'm going to draw the arcs with this corner as a center and the line which I have drawn now as my radius. the line which I have drawn now as my radius till the opposite line. I'm going to draw it till the opposite line. Similarly, with this corner as a center and the line which we have drawn as my radius, I'm going to join it to the opposite line. This is what I'm going to draw it here. Then with this point as center and the line which we have drawn as my radius on the circle, I'm going to complete the arc. Similarly, with this point as center and the line which I have drawn, I'm going to draw the arc. Okay. So the bottom base of 60 mm, I have already done it. Now what? The height of this frustum of a cone is 60 mm. So what I'll do is all these four points, corners, what I have, I'll extend it to 60 mm above. So from this corner, it is 1, 2, 3, 4, 5, 6. Then from here, it is 1, 2, 3, 4, 5, 6. From this corner, it is 1, 2, 3, 4, 5, 6. From here, it is 1, 2, 3, 4, 5, 6. So I have got the corner for which first is what I'll do is I'll just close this up. Four corners at a height of 60 mm I have got. But this is not the exact square I'm going to draw it here. Why? Because see this is the bottom base of 60 mm diameter. I have, this is my 60 mm diameter which I have drawn. The bottom base is 60 mm diameter which is drawn. So this is my 60 mm diameter. This square block I have drawn, and the same has been raised up to 60 mm. The height of this is 60 mm. The height of this frustum of a cone is 60 mm. So what I did, I have raised the same corners at 60 mm. But as what I have at 60 mm is not of 60 mm diameter, but the top base circle is of 40 mm. So what I do is now I'm going to draw a square block here of 40 mm, that is at a height of 60 mm in the isometric projection. Then there again I'm going to draw the ellipse using the same method. So what I'm going to do is this 60 mm block I need to convert to 40 mm. That means what I'm going to do is each side how much it has to be reduced. From here, this is this length from here to here. If I consider, say suppose this is I consider this as 4, 4 is over, this as 5, 6, 7 and 8. Corner number 5, 6, 7 and 8. If I consider these four corners, if I want to draw using a midpoint, if I want to draw a square block of 40 mm, this total is 60. That means 60 minus 40 means how much it is left? 60 minus 40, how much is left? It is 20 mm. 20 I need to leave to, not from one side, I need to leave from both the sides. So 20 divided by 2, it is 10 mm. That means one block is nothing but 10 mm. So each side one block I need to leave. So from here one block, so from here one block, and from here one block, from here one block, from this line one block, and from this line one block, from this corner one block, and from this corner one block. So what is left? I have got a square block of 40 mm here. This is my square block of 40 mm which I'm going to get it here, leaving each side one block each side. So I have drawn a square block of 40 mm on each side. So this is what I'm going to draw. Okay. So now this is the square block of 40 mm. So here I'm going to draw a ellipse of 40 mm. So for which what I'm going to do is from this corner I'm going to join the opposite midpoint length side of the opposite edge. So again from this corner I'm going to join the midpoint of the opposite edge. From this corner I'm going to join the midpoint of the opposite edge. Once I'm done with this, again with the line which I have drawn and with the corner as my radius, I'm going to draw a circle. That is a arc. I'm going to draw the arc. Similarly from here with the new radius, I'm going to draw the arc. Then with this as a midpoint and this as a radius, again I'm going to draw a arc. Then from here with this point as a center and this point as a radius, I'm going to draw the arc. Okay. Once this is done, I'm going to join the tangent of these two. I'm going to join the tangent of these two. So this is my frustum of a cone. That is this part, this circle, which is looking like a ellipse in the top base in the isometric projection, and this is the bottom base of 60 mm diameter, which looks like a ellipse in the isometric projection, and it is joined by a slant edges. Now the last part of the problem is I have a 45 mm sphere. I have a 45 mm diameter sphere. 45 mm diameter sphere. And sphere in always, sphere means what? It is nothing but a circle. Sphere means what? A ball. Or for example, your cricket ball. You see cricket ball in at any angle from anywhere. You see the cricket ball from any angle and from anywhere, it looks like a circle only. Am I right? So always, whether let it be a isometric projection or let it be a 2D projection, a circle will be a circle always. A circle will be a circle always. Now what I need to do is I have to identify the midpoint of this 40 mm diameter square. So this is my midpoint of it, and from here the diameter is 45 mm. So what happens is I need to count the number of blocks here, that is 22.5, that is 2.5. That is, this is, if I consider this portion, it is a half. 22.5, that is I need to go with this total. If I consider this is a half, so what happens? How do I consider this? How do I consider this? What happens to it? So I count the number of blocks here. I count the number of blocks. This is 10, 20, and this is 25, right? Half of this again. Half of this means again half of this I have somewhat here. Okay. So if I go here, it will be 25. And if I go to this point, it will be 30. So this is the midpoint of a square block at the height of 60 mm from the bottom base. This is one block 10. This is second block 20. If I go next block half, it will be 25. Half of that will be giving me how much? 22.5. So what I do is I just count the number of blocks with the isometric projection. This is 22.5 now. This, whatever I have got, is 22.5. Then the sphere circle, I'm not going to measure the radius here. This is the length. This is the length in isometric scale. This is the length in isometric scale, but a sphere will always look like a sphere, whether let it be in isometric scale or let it be in a 2D drawing. So what I do is I have to measure it in a scale. I have to measure it with the scale that is 22.5. I am going to measure it with the help of a scale that is 22.5. I'm going to measure it with a scale 22.5. Then this as a radius. This as my center point. With this as my center point, I'm going to draw a circle. With this as a center point, I'm going to draw a circle. I'm going to draw a circle. That is a sphere. I'm going to draw a circle, a sphere. Okay. Now see this. This is very important. I repeat, I have counted to know the midpoint of this sphere. To know the midpoint of this sphere which I have drawn, I have counted the number of blocks. That is 1, 2, 2.5. That is 22.5. If I had counted till this point, it would be 25. I've counted half of that, it will be 22.5. So this is my midpoint. Then from this midpoint, what did I do? I have measured it with the help of a scale, that is 22.5. With the help of the scale, I have measured 22.5. Then with the new dimension, with this as a center point, I have drawn a circle. Now when I draw a circle, this is the midpoint of a square block what I have drawn here. This will always be below the center point. This circle, whatever I have drawn, it will always be below this center point. If it comes exactly to the center point, that means you have drawn the ISO circle. You have drawn the ISO circle. But I'm not going to draw the ISO circle, that is isometric circle. I am going to draw the circle of 45 mm, measuring it with the help of a scale. So this is the length of the ISO to find the midpoint. Once I get the midpoint, from the scale I'm going to measure it with 22.5 and I'm going to draw a circle. This circle will be such a way that it will be below the midpoint of the bottom square which I have drawn. The square block, always whatever the square block I have, it will be always below that. So once I understand a circle, then it will always be a circle. Okay. If you have any doubts, you can just ask.
Sir, that
Just in a short span of time, we will check out how to draw a cone and a hemisphere. Both I'll take it in one diagram. So I'm drawing a cone of 40 mm, 60 mm diameter cone. So this is a square block which I'm going to draw. Then I'm going to join the midpoint of the opposite edge from the corner, midpoint of the opposite edge from the corner, then midpoint of the opposite edge from the corner, and midpoint of the opposite edge of the corner. Then I measure it here from this end. I measure it. I draw the arc. Then I measure from here. I draw the arc. Okay. Then from this point, I'm going to draw the another arc, and from this point, I'm going to draw the other arc. Okay. Once this is done, I know this is the midpoint of this square block. If I have a cone of height 60 mm, I'll just count the number of blocks as 60. 1, 2, 3, 4, 5, 6. 6 blocks. This is the center point. I'm just going to join the tangent here. Just going to join the tangent here. Okay. This is nothing but a cone for me. This is nothing but a cone. Say for example, this is the tangent which I'm going to draw from the midpoint. Okay. From the midpoint, whatever I'm going to draw, this is the tangent. Okay. So this is nothing but a cone. This is nothing but a cone. Say for example, I don't want a cone, I want a hemisphere. I want a hemisphere. If they have asked me a hemisphere, the top one of a hemisphere, how it will be? This will be a circle and then a cut section. Hemisphere is nothing but a cut section of a sphere. So when I cut this circle, what happens? This top base, I have a circle, then it is joined by a bottom arc. So this is a circle. In a ISO scale, circle will be converted to ellipse. So this is what I'm going to draw the ellipse. Then I'm going to draw the bottom circle. The bottom circle, directly I'm going to draw it from the midpoint. From the midpoint, I'm going to measure the length of the arc of this. I'm going to measure the length of this arc. I'm going to measure the length of this arc. Then I'm going to draw the semicircle. I'm going to draw the semicircle here. Okay. It meets at this point. It meets at this point, and it is meeting at this point. So this is the arc, bottom arc, whatever I have drawn here, and this is the top base, which was a circle, which will be converted to a ellipse. So this is nothing but a hemisphere. Hemisphere. Okay. So I have thought how to draw a frustum of a cone, how to draw a frustum of a cone, how to draw a sphere, how to draw a hemisphere, as well as how to draw a cone. Okay. So is it clear, everyone?